check this question which we tried last time.
Yeah.
Okay, from this you get 5 into 5, 25 minus 5 is 20, the blue one, right? And then 4 into 7 raised to the power k, this one. Right? So if I take 4 out, it will become 5 plus 7 raised to the power k. Okay, now I have to show this is basically divisible by 24. That is the question. 4 factor is here, so this is divisible by 6. Now we have to check that one. Is that okay? 4 factor is outside. Yes or no?
Yeah.
We have to check whether it's divisible by 6. Okay, so for that again we'll do induction. We'll assume this is true for k and this is k plus 1. So this we have to check whether it's true or not. Okay, so this you can write as this one. 7 times 7 raised to the power k. So it will become 6 times 7 raised to the power k plus this one, 5, 6a. So here there is a factor of 6. So this is divisible by 6. So the whole thing is divisible by 24. Is it clear?
Yeah.
Okay. Right. What about Daksh?
Yes, I got it.
Okay. This also last time we got stuck. Okay. Here there are two statements. No? The statement one is this one. This is divisible by 7. Statement 2 is n raised to the power 7 minus n is divisible by 7. Sometimes it's easy to check the statement 2 first and then the statement 1 later. So if we try to check the statement 2, okay, so n raised to the power 7 minus n is divisible by 7. Assume it is true for k. Okay, from that we have to check for k plus 1. Okay, and there is one important result of binomial theorem which states this one: x plus y raised to the power n. So can you guess what will it be? The n is a natural number. This is what x plus y into x plus y. How many times?
N times.
N times, right? So you'll get x raised to the power n maximum. The power of x maximum will be x raised to the power n. Okay, that will be one term. Other term will be x raised to the power n minus 1 y. Getting it? I take x in n minus 1 factors and y in 1 factor. And similarly, I'll get another term as x square n minus 2 y square. If you sum the powers of x and y, it will be always n. Okay, so that's what is happening here. X raised to the power n, x raised to n minus 1 y, n minus 2 y square, y, 1, y raised to n minus 1, and then 0 and n. Is that clear? The only thing is the coefficients. Okay, right now we just assume this result. This is notation for example, this is NC2, which is n into n minus 1 divided by 2 into 1. This you will learn later. It's called binomial theorem. Okay, right now just accept it because we need to use this result. Okay, so that's what we are doing here. K plus 1 raised to the power 7. So it will be a, this will give me terms of the power k raised to the power 7, k raised to the power 6, like that. Getting it? K raised to the power 7 and then k raised to the power 6 will be here. K square, k, and then the constant term. K raised to the power 0. Okay? We are just using this result. Okay? Y is 1 will be x raised to the power n, polynomial in x raised to the power n. So this will be polynomial in k raised to the power 7. Okay, so k raised to the power 7, 6, 5, like that, k and then constant term. The coefficients will be like this. Okay, and this k plus 1 is there. So k I can write as k minus k raised to the power 7 minus 7m. This is k plus 1. Okay, so and the coefficients are 7c0, 7c1 like that. Right now just accept it, we'll learn it later. And 7c0 is 1, so this will cancel with 1 here. Okay, and 7c7 is 1, so this will cancel with this one. Okay, the remaining terms will have 7c1, 7c2 like that. And 7c1 is 7, 7c2 is 786 divided by 2 into 1, 7c3 is 786 into 5 divided by 3 into 2 into 1. So everywhere there is a factor of 7. Okay, and 3 will cancel with this one, 2 will cancel with this one. So everywhere there is a factor of 7. So this is true. Okay, we have used this one here. Okay, so P of k true implies P of k plus 1 is true. Is that okay? So statement 2 is true, and we have proved it by mathematical induction. Is it clear? Statement 2 is n raised to the power 7 minus 7 is divisible by 7. So I assume prove it by induction. So yeah, I'm assuming k and I'm proving for k plus 1. Daksh, is it clear? Daksh? Daksh?
Yes,
You
sir.
there? Is it clear?
Yes, sir.
Okay, notes will be there, and then you can check and you can WhatsApp me if there is any doubt. Okay.
Okay, sir.
So second statement we have proved it. Using that, we'll try to prove the first one. So first statement is n raised to n plus 1 raised to the power 7 minus n raised to the power 7 minus 1 is divisible by 7. So let me put n equal to k. So this we have to prove. And k plus 1 raised to the power 7, again we use the binomial expansion. Okay, so this is this one, polynomial in k raised to the power 7. And the coefficient will be 7c7, 7c6 like that, 7c0. And then minus k raised to the power 7 minus 1. So this will cancel with this one. 1 will cancel with this one. 7c0 is 1. And k raised to the power 7 will cancel with this one. This and this will cancel. The remaining terms will have 7c1, 7c2, everything, up to 7c6. We will have 7 as a factor. So statement 1 is correct. This is also true. The option is 2. Statement 1 is true, statement 2 is true, and statement 2 is correct explanation for statement 1. We are actually using this usage by 7. Okay. Right. Is it clear?
Yeah.
Yes, sir.
Okay. Now this is a new problem. Let's try this one. Again, it's most probably to be true that statement 2 is easier to check. Okay. So statement 1 and statement 2 are given. Try to check statement 1 and also try to check statement 2. If statement 2 is easier to check, first do that one. Let's check whether it's true or false. Because the options say that statement 1 is false, true, something like that. If you check whether statements are true or false. Statement 2, whether it's true or not.
Sir, I did.
It's obviously true, no?
Yeah.
Okay. Now, what about statement 1?
It's also true.
Did you do it properly? Okay. So which option is correct then?
3.
Okay. Right. Daksh, what about you?
3 only.
Statement 2. This is checking for statement 2. You can square both the sides. Squaring will not change the inequality. This square root means actually plus. Okay. And n is a natural number greater than or equal to 2. So right hand results are positive. So when you square them, it will still, the inequality is still full because both LHS and RHS are positive. But if one of them is negative, do not be true. For example, minus 4 is less than 2, right? If square this, it becomes 16 less than 4, which is not true. Okay. But if both the sides are positive, then the inequality will still hold. So here both left hand side and right hand side are positive. So that's why I can square it. Okay. So statement 2 is true.
Okay, sir.
Daksh.
Yes, sir.
Okay. Now we have to use the
But made by trial and error.
trial and error. No. See, trial and error will give only for particular values of n, no?
Yes, sir. So I'm asking how will we prove it in equation?
No, that's what I showed you right now. Square both the sides and you can cancel n, right? N plus 1 because it's positive.
Okay.
Positive numbers you can cancel on both the sides of inequality. Okay.
Okay.
For example, minus 2 is less than minus 1, right?
Yeah, sir, I understood that. Okay.
2 is less than 1 is not true.
Yeah.
Okay. So I can cancel positive numbers on both the sides of inequality. The inequality is still full. And then statement 1, P of 2 is true. Okay. And assume P of k is true.
Yeah.
Okay. From the P of k plus 1 is this plus this one. You have to check whether this
Yeah.
is true. So simplify it. You'll get this one. So k is greater than k, which is true because k is greater than or equal to 2. You can cancel k on both the sides and still the inequality hold because k is positive and it's greater than or equal to 2. So that's why I'm able to cancel k.
Okay.
Rather k plus 1. Square k square. Okay, I'm squaring and then I'm cancelling k. Squaring I'm allowed because both sides are positive and I'm cancelling k because k is positive. Daksh, is it clear?
Yes, sir.
Okay. Inequalities, if you multiply negative sign on both the sides, negative number on both the sides, then the inequality sign will reverse. For example, 2 is less than 3, right? If I multiply by negative number, say minus 2 on both the sides, then the inequality sign will reverse. It will be minus 4 and then minus 6. Minus 4 is greater than minus 6. So inequality sign is reversing here to here because I'm multiplying by negative number. Okay. What about this one?
I didn't understand this only. I had tried at home, but
Okay. See, first of
So
all,
where was this problem?
as
Allen sheet.
Oh, okay. I didn't. It's not in the PDF. So.
Yeah, I didn't give it to you. Okay. Okay, he's saying it is seen that P of n implies P of n plus 1. You can check that, but it's not necessary because he has already given it. So therefore, P of n is true for, see, this is true if P of n is true for any finite value of n. I have to check for n equal to 1 or 2 or some number. If there is true, then for, say for, it is true for p of 5. Then I can say by induction that it is true for all n greater than 5, greater than or equal to 5. Okay, so n square plus n is n into n plus 1. There are only two possibilities. If n is even, this is odd, right? And if n is odd, this second factor is even. Okay, so whenever I multiply any number by even number, the thing will be even. Right? Even into odd is even, and even into even is also even. Okay, so this thing will never be true.
So none of these.
Yeah.
Okay.
But p of n implies p of n plus 1. That is true. But p of n itself is not true in this particular case for any number.
So this is easy, right?
Yeah, yeah. It's an Allen sheet question, not a main problem or something. So
Okay.
just get used to your thinking. Not it won't come in the exam. These sort of questions. Okay, it's not examination question. It's just an exercise question. This is an examination question. Okay, mains.
Okay.
This also mains.
Okay.
Statement 2 might be easier to check. Okay, this was Allen sheet. So for all n, yeah, not a good question, but still we can do it. N equal to 1, 7 square. N equal to 2, 7 raised to the power 4, minus 48. 2304. Okay, yes, calculated 2304. Okay, so obviously these options will drop out because this is true for all n. Okay, when I'm checking for 2, I'm getting this value of this whatever is given as 2304. So obviously it's not divisible by the small numbers. It is only divisible by this one. And only there are 4 options. So one of the options is correct. So fourth one is correct. Is it clear?
Okay.
Not a
Yeah.
good question. It's just an Allen exercise. And the solution he has given is that only. P of 1 is found as 0. 0 is equal to 0 into any number. So P1 is not eliminating anything. But P of 2, the value is 2304. So option 1, 2, 3 are gone. The only remaining option is 4. So the correct answer is 4. You have to say yes or no. Right. Okay. This was Allen sheet question. The nth term of the series 4 plus 14 plus 30. Bobby, did you try this one?
No, sir.
We have given the solution. Right here, there is one interesting technical letter to learn. Unless you know that, you will not find the answer. Okay, first of all, look at the terms. Is there any pattern?
Yes, sir. Every time the increase increases by 6.
What is the increase? First term to second term?
So between the first and second term, it's 10. Between the second and the third, it's 16. Then it's 22. Then it's 28, and so on.
10, and this is what?
16.
16.
Okay, this and this?
22.
22.
This and this?
20.
20, right?
28.
Okay, so what is the pattern then?
Adding 10 first and then 6 consecutively.
Yes. So this thing is an AP, right?
Yeah. AP.
Okay. So the difference between the two consecutive terms is an AP with the difference as 6.
D.
So when you have something like this, there is a standard way of doing this. Let me call this as S. Okay. So I can also write S as 4.
n by 2 to plus n minus 1.
No. That is for this one. This is not AP, no?
Yeah.
That is not AP. So I cannot use sum of AP terms. The last term, let me call it as Tn. Okay. Here also the last term is Tn. Now I'm going to subtract these two. Okay. So right, left hand side will be 0. Subtracting, I'll just subtract 0 with 4. 4 with 0. So it will be 4. And then 14 minus 4, that is 10. And then 30 minus 14 is 16. Plus so on. Plus Tn minus, okay, I'll get minus Tn. Yeah, minus Tn, and then Tn minus the previous term. Okay, so up to this one, it will be in AP. The first term is 4, common difference is 6. Correct. After that, this plus Tn will come as this one minus Tn here. Is it clear? I'm just shifting the second sum by one term to the right. Okay, and then I'm subtracting. Okay, so 4 minus 0 is 4. 14 minus 4 is 10. 30 minus 14 is 16. And the last term Tn minus that last part one term here, it will give me some number. Let it be there. I know the number of terms here, that is n. This is AP of n terms. And then this Tn is minus Tn. Clear? Daksh?
Yes, sir.
Bhavya?
Yes, sir.
Okay. So this sum I can write now. N by 2 into 2a is 8 plus n 1 6 minus 4. So from this I'll get Tn as this one only. Tn will become equal to this one. So which option is correct? 4n plus 3 n into n minus 1. 3n square. So this I can simplify further. 3n square minus 3n square plus n. So option 3. Only the option is 3. Okay, this is a standard method of doing it. You find the difference between the two consecutive terms is in AP. Then you write the sum with one term shifted towards the right. And then you subtract them. Don't scribble. And we subtract them. So the one which I marked as n terms is in AP. And I know the number of terms. These 8 terms. Okay, that I can write as sum as this one. Is it clear?
Yeah.
Daksh?
Yes, sir.
Okay, the formula for sum of n terms of an AP is n by 2 into 2a plus n minus 1 into d. Is it a long time back? Okay, so if you don't know, just use this result now. Okay. What about this one? 20 to the power n plus 3 times exactly divisible by 9 for all n. The least possible integral value of lambda is. Again, this is an Allen sheet question, so don't bother much. But just for the sake of learning, you should do this problem. Again, by elimination, you can have to eliminate.
Yes, it will be 5.
Yeah. Basically, I put values n equal to 1 to 3. I'm getting my numbers as remain 9 into something I'm getting, and then the remainder is 4 everywhere. 9 to something plus the remainder is 4 always. Remainder is 4.
Yeah.
So the lambda should be 5 to make it divisible by 9. Plus lambda is there. Okay, so that way, since lambda is 5, and is saying the least possible value of possible positive integral of lambda. So I can eliminate 3 and 1. Okay, and 7, if I add 7 to this, then it won't uh, be divisible by, for any equal to 1, if you put lambda equal to 7, then it's not divisible by 9. So the only option is 5 then. Is it okay?
Yes, sir.
Okay, it's a RN sheet question, so don't bother much. Okay, what about this one? This is a good one. If you know trigonometry, you have to use trigonometry formula.
I can't see the question. Okay, yeah.
And as far as mains is concerned, the mathematical questions repeat themselves. So if you solve previous year's JEE main questions, then you'll get the pattern of the question. So these sort of questions, once you've already done it, then it's easy. Otherwise, you just have to, you may take a longer time. Okay, from the option itself, you should get some idea. Sin theta is there in the denominator, right? And at least
Yeah.
there are 3 options. So what can you do with this one then? Multiply and divide by sin theta. Okay,
Okay.
and then sin theta cos theta you can combine. If you combine sin theta cos theta, what will it become? Sin 2 theta formula is what? Sin 2 theta is what?
Theta cos theta.
2 sin theta cos theta. Okay, so multiply and divide by 2 sin theta because that's why 2 is appearing here, the denominator. Okay,
So it will be 4.
yeah, multiply and divide by 2 sin theta and then combine 2 sin theta cos theta. So that will become sin 2 theta, and again you can combine sin 2 theta and cos 2 theta. That will give sin 4 theta. Again you can combine sin 4 theta and cos 4 theta. You got it now?
Yeah.
Just look at the pattern now. Okay, when 2 is here, I'm getting 2 here. I'll get to this. Then you have to look at the pattern carefully. At this stage, when sin 4 theta is there, I'm having 2 square. Okay, the last one is 2 raised to the power n minus 1 into theta. So finally, I'll get 2 raised to the power n into theta. Okay, so when 2 raised to the power n is here, the denominator has got 2 raised to the power n. Okay, because when 4 is there, denominator is 2 raised to the power 2. When 2 raised to the power n is there, denominator is 2 raised to the power n. Sin theta is always there. It just came out once. After that, you just have to keep combining. So 25, the answer is 4. Sorry, it is sign, no? When you combine, you get sign, not cost. Don't scribble. Why are you scribbling? This is sign. You combine, you get sign. 2 sin theta cos theta is sin 2 theta, not cos 2 theta. So option 1 is correct. Is it clear? Daksh?
Yes, sir.
Yeah. You have to combine this thing and then you have to look at the pattern carefully. When sin 4 theta is there, it is denominator is 2 raised to the power 2. So finally I'll get sin 2 raised to the power n into theta, so denominator will have 2 raised to the power n. Okay. Real. This is the definition of mathematical induction, right? Principle of mathematical induction. What is the answer?
Sir, third option.
Which one? Yeah.
Third. Okay.
This is basically principle of mathematical induction statement.
Sir, such theory questions come in exam.
No. This is Allen sheet question.
Okay.
This is just to help you understand the concept. This will not come in exam. Daksh? Daksh, is it okay?
Yes, sir.
Okay, for every natural number is always, this is also a trivial question. What is the answer?
Sir, first multiple of 4.
Every natural number, no. For n equal to 1, yeah, 1 into 4, that is true. N equal to 2 times. No. If you put
No,
n
sir,
equal
that's
to
not.
So it doesn't work for 2. Even. The answer is even.
even is definitely true because if n is odd, n plus 3 is even. If n is even, n plus 3 is odd. So whenever you multiply by even, you always get even. So option 3 is definitely true. The only thing you have to check is whether 1 is true or not. 1 is not true for n equal to 2. So you can rule out 1. Okay, you can rule out 1 because of n equal to 2. Right? Only thing is we choosing between 1 and 2. And you can rule out 1 because of n equal to 2. Fine. Okay. Simple question, but this one catch is there. Okay. What about this one? For positive integer. So you basically find the minimum value of n. For first of all, you have to check whether it is true for. You have to check whether it's true by mathematical induction. Because for all n greater than something, it is true, right? So you have to check whether it's p of k implies p of k plus 1. Getting it? Assume that p raised to the power k is less than k factorial. Assume this one. Now we have to show that p is equal to k plus 1 is less than k plus 1 factorial. This you have to show. Okay, this is 3 raised to the power k into 3 related to k plus 1 k factorial. The meaning of k factorial is suppose 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay, so k plus 1 factorial is k plus 1 into k factorial. Okay, so